previously we saw few sorting algorithms and all of them have time complexity of n square. This is the first time that we will be seeing a sorting algorithm that will have a time complexity of n log n. In this video, we will learn about something called as merge sort. Merge sort is also dependent on a very important technique called as divide and conquer. Now this technique we will be using to construct a segment tree, to solve the problems like binary search, to solve the problems like inversion count. Lot of things are actually dependent on this divide and conquer technique. So I highly recommend you to watch it carefully, go through it twice. Okay, let's go through the sorting theory. Given an array that contains n element, our task is to sort the elements, that means arrange in increasing or decreasing order. If you see the first array, all the elements are pretty much random, but if you look at the second array, all the elements are arranged in proper way in an increasing order. So our primary task will be to convert the first array into the second array. Let's get started with the merge sort. As I mentioned earlier, merge sort uses a technique called as divide and conquer. We need to solve the problem at the time of divide or at the time of merge. As the name suggests, it is a divide and conquer technique, correct? So divide means given a problem statement P, you are going to divide it into further P1 and P1, let's say. Then again you will divide it further, something P2, P2, something like this. And after the division is completed, you will merge it back and construct the solution for P. That means you will go back. So you have P2, P2 here. From that you will construct the solution for P1, and from that you will construct the solution for P. So the left side is a divide side, right side is a merge side. So you need to solve the problem at the time of divide or at the time of merge. So the sorting algorithm that we are seeing in this video will solve the problem at the time of merge, while the quick sort that we will see in an upcoming video will solve the problem at the time of divide. So I have selected these two sorting algorithms purposefully so that we can learn divide and conquer technique as well. So we are going to divide the input array into two parts. That is very clear. At the time of merge, we will try to solve the problem. What is the problem that we have? Given an unsorted array, we need to arrange the elements in such a way that ultimately you will get a sorted array. This will make much more sense to you once we take an example. So this is the input array that we have, 3, 10, 5 and 2. There is no order to it. Elements are pretty much random. So you divide the array into two different sections, left and right. Again you divide it further till you have an array with length 1. See, all these arrays, there are 4 different arrays and all of them have length 1. Till we have length 1, we will be dividing it. Once we have the length 1 array, now we will start our merge operation. And remember, merge sort solves the problem at the time of merge. So how exactly are we going to solve the problem? So these are the two arrays that we have, 3 and 10. We are going to merge them together and create an array of length 2 where elements will be in sorted order. So we take 3, place it here, and we take 10 and place it here. I hope that is clear. Look at the second portion as well. We need to create an array with length 2 by merging these length 1 arrays. So we take the smallest number, which is 2, and place at the first position of our resulting array. Similarly, we take the next smallest number, which is 5, and place it in the second position. And that's how we get a sorted array here. Now we have these two arrays of length 2, correct? We are going to merge these two arrays into a single array of length 4 in such a way that all the elements in the final array will be sorted. So how exactly are we going to do it? So let's say you have iterator I here and you have an iterator j here, pointing to the very first element of the left array and pointing to the very first element of right array. So this is going to be our left array. We will refer it as by L. And this is going to be our right array. We will refer it as R. So our observation is that left array is sorted array. Right array is also sorted array. So the very first position in the resulting array will be taken by either I or J. Why? Because all the elements to the right side of I will be greater than the ith element. That means all the element to the right side of 3 will definitely be greater than 3. Remember, this L array is a sorted array. So all the elements to the right of 3 will be greater than 3. Same goes for the R array as well. All the element to the right side of 2 will be greater than 2. Why? Because this R array is also a sorted array. So that means the very first position in the final resulting array will be taken by either the ith element or the jth element. Whosoever is the smallest element will take this position. In this case, 2 is the smallest element, so 2 is going to take the position. So the processing of 2 is done. Now our jth iterator will point to the next element, which is 5. Again the same thing will happen. We will try to select the smallest number. So the second position will be taken either by the ith element or jth element. Again by the same logic. Why? Because all the number to the right side of 3 are going to be greater than that, and all the number to the right side of 5 are going to be greater than 5. Because R array and L array, both of them are sorted arrays. So who is going to take the second position? Ith element or jth element? Well, whosoever is the smallest element will take the second position. In this case, 3 is smaller than 5. So 3 is going to take this position. So the processing of 3 is done. We will move our I pointer to the next element. By the same logic, you have jth element as 5 and ith element as 10. So who is going to take the third position? Well, the smallest element is going to take the third position, which is 5. And jth iterator will point to the next. So the processing of one array is done. That is the R array is done. So we have completely processed the R array. That means the only array that we have is L array, right? So all the elements remaining in the L array are already sorted, we know that. So we are just going to copy all the elements from the L array and put them into our resulting array. Here the only element left out is 10. So we are just going to take it and put it in the last position. For this algorithm to work perfectly fine, left array and right array, both of them needs to be sorted. And that's why we divided the array till we reach length 1. Because we know that length 1 array will always be sorted. And our algorithm works when left array is sorted and right array is sorted. If you look at this carefully, every single element will be processed only once. Once we take this element 3 and place it in its correct position, we move our iterator I to the next position and we will never process the element 3 again. So every single element will be processed only once. So this is kind of a two-pointer approach, and the time complexity of moving from this step to the final step is going to be O of n. Why O of n? Because every single element is processed once, and how many elements do we have here? Exactly n. Same thing goes for here as well. From moving this step to this step. Why? Remember, we merged 3 and 10 to get this array, and we merged 5 and 2 to get this array, and we processed every single element once. Correct? So how many elements are there? At every single stage we have exactly n elements. So the time complexity of moving from one stage to another stage will take O of n time. I hope this is clear. See, at any given stage, this is stage 1, this is stage 2, this is stage 3, which is the final stage. At any given stage, you have exactly n elements, and you are processing every single element only once, right? Once that element is taken into the next stage, we never process that element again. Correct? So at every single stage, the time complexity is O of n. We will discuss time complexity further on as well, but by this example, merge sort is very clear. What we are doing, we are first dividing the array into two different sections. We divide till we have an array with length 1. See, all these arrays have length 1 only. Once that is done, well, we merge And our merging algorithm is very simple. We have a left array, we have a right array. Left array is sorted, right array is sorted, we know that. We take two pointers I and j. You can take third pointer which will point to the resulting array, and we call that pointer as k. This k will be increasing continuously. So when k is equal to 0, we want the 0th element in the final array. When k is equal to 1, we want the very first element in the final array. So we have the left array, we have the right array, we have three pointers I, j and k. Now we have the logic. Let's try to convert that logic into a code. And ultimately we need to write the code. So you need to think in terms of the code. See, when you see all these arrays in front of you, it's very easy to say that the process is very simple or the algorithm is very simple. The complicated section is not to derive the logic, but to write that logic or convert that logic into a code. If you do this multiple times, if you try to solve the problem, derive the logic, convert that logic into the code, ultimately you develop a mind that will directly look at the problem and directly translate that problem into a code. You will skip that developing a logic step entirely, and that's how you gain the speed. As we mentioned previously, what we will do, if you have an input array, let's say that is ARR, you have 3, 10, 2 and 5. We split the array into two different sections, left and right. We copy these elements into a left array and we copy these elements into right array. We are creating two new arrays, left array and right array. Why? So whatever the arrangement that we create finally will be updated into the input array itself. So this is our ARR. Okay, so what is the step 1? The step 1 is very simple. We split the array, we take the left portion, we create a new array called as left array or L array, and we copy all the elements from the left portion. And we copy all the elements from the right portion into the R array. So this is our step 1. Now let's go to the step 2. What is the step 2? Well, in step 2 we are going to initialize all the pointers. So this is our pointer I, this will be our pointer j, and this is going to be our pointer k. Now we will start the processing. We check whether I is less than j or not. If I is less than j, then we will assign I here and we will increment I. If j is less than I, then we will assign j here and we will increment the value of j. Correct? So in this case, the value of j is less than value of I. So we take this element 2 and we place it here. Now the processing of 2 is done. Now we will move our pointer j to the next position, which is 5. Again, we do the exact same thing. We compare the value of I to the value of j. Which value is less? Well, value of I is less than value of j. So we take the value of 3 and we place it here. We will increment the value of k. Now k is pointing to this third position, correct? Again, we will increment the value of I as well. The processing of 3 is done. Now the question is, who is the smaller, I or j? Well, j is smaller, right? So we take the element j here, which is 5. We increment the value of k. K is going to point here. And we increment the pointer j. Now the processing of the R array is done. If the processing of any of the array is done, then we will break this loop. Now we know that all the elements that are left out will definitely be in increasing order. So we just take those elements and put them into the final answer. By using this L array and R array, we managed to write the final answer into the input itself. See, this was the input 3, 10, 2, 5. And what we did, we managed to put all the elements in correct order in the given input itself. We will have 3 pointers I, j, k. This is our step 2. Step 3 is that we are going to start a loop, a while loop using I and j as an iterator, and we will do the processing. We will check which value is less. We will assign that value to our final array and increment that particular pointer. Once the processing of any of the array is done, in this case, we completed the processing of the right array. All the remaining elements from the other array will be copied to our final answer as it is. Now let's look at the code. See, this is the input array that we will have. And we will have two different variables, left and right. These left and right variable will maintain which section of the array that we are sorting. See, the final answer will be directly updated to the given input, right? So we are not going to split the array or bifurcate the array. Rather, we will keep two variables, left and right, to maintain the start and the end position. These two variables will provide us the section from the entire array to sort. Correct? We will take a look at how exactly this will look like for the given example. But we are not actually going to split the array. This array will be passed as a reference because we are updating the answer into the array itself. In majority of the divide and conquer approaches, you will see a recursion. Recursion we use to divide. Right? So first we find the mid portion. Then we call merge sort from left to mid. Then we call merge sort from mid to right. So this will sort our left portion. This will sort our right portion. Then we will merge the left and right portion here. Remember, in merge sort, we solve the problem at the time of merge. So first we divide into left and right. Then we merge and solve the problem. Okay, so let's look at the merge code. Remember what we said, we will create left array and right array. We will iterate on the array and copy everything into the left array and copy everything into the right array. Okay. After that we initialize three different variables, I, j, k, right? Now why k is left? Remember, array is passed as complete whole array. This left pointer will tell us the starting point and right pointer will tell us the ending point of the array which we are going to sort. So we have a while loop. I should be less than n1 and j should be less than n2. What is n1? Well, n1 is the length of the left array and n2 is the length of the right array, right? So I should be less than the length of n1 and j should be less than length of n2. So we check whether ith element is less than the jth element. If that is true, then we take the ith element and increment the I pointer. If jth element is less than the ith element, we take that jth element and we increment the iterator j. The iterator k will always be incremented. See, k will be pointing to the array, right? See, this is our variable k. That will be incrementing. So no matter which element you take element from left or you take element from right, our value of k will keep on incrementing throughout the solution. Okay, so the first step is done. We copy and create left and right array. Second step is also done. We process at least one array completely, left or right. And in third step, as we mentioned earlier, once the processing of any of the two arrays is done, then we copy all the remaining elements from the other array into our answer. So imagine the processing of our array is done. So you copy all the elements from the left array into our answer. Same thing, imagine the processing of left array is done. So you copy all the elements from our right array into our answer. Majority of the times when we use divide and conquer, we will use recursion. In segment tree, or there are many other algorithms like in quick sort as well. Whenever we want to divide, this is the process that we follow. Generally, in general case, we take the mid element, we call the same function. We use these two elements, left and right, to keep the track of the section of the array that we are solving. See, array might be this, but left pointer might be here and right pointer might be here. So we will be solving this portion only. Correct? So let's look at how it will look like. In all the stages, you will have your array. Initially, left is going to be 0 and right is going to be 3. So left is this 0 and right will be this. So you divide. Mid here is going to be 1. So this is the left section of the array and this will sort the right section of the array. Look at this. Left is 0, right is 1. That means in this particular merge sort we are directly dealing with the left section. And in this section left is 2, right is 3. So we will be dealing with this right section. Again we will divide it further. Left is 0, right is 0. So we will be dealing with this. Left is 1, right is 1. So we will be dealing with this number. Left is 2, right is 2. So we will be dealing with this number. Left is 3 and right is 3. We will be dealing with this number. We are not splitting the array actually. We are maintaining two variables left and right. That will tell us the portion of array that we are going to solve. Now let's look at the merge. See this is the final stage that divide gave us, correct? So left is 0, mid is again 0 and right is going to be 1. That means we are dealing with left is 0 and right is 0. That means we are dealing with this array. Mid is 0. So left will be this, right will be this. We will iterate on the left array, we will iterate on the right array, and whatever the answer is we will update directly into our given array ARR. Same thing goes here. See, left is 2, right is 3. That means here we are dealing with this portion. So we want to solve this right section only. We don't care about the left section. That will be handled by this call. So first what we do, we create a left array and we create a right array. Correct? Left array is going to be 5, right array is going to be 2. And then we rearrange the elements by using the logic that we just discussed and update the values into our final ARR. So this will look something like this. 2 and 5. Right portion correctly sorted by this. Left portion correctly sorted by this. We just want to merge these two together. Look at this. Left is 0 and right is 3. That means now we are dealing with the full array. Mid is 1. Well, we create left array again and we create a right array. This right array will deal with this right section and this left array will deal with this left section. And now we are going to merge this left and right section into our final answer. And we have already saw how exactly we do that. We take the smallest element, then we take the smallest element, then we take the smallest element, and then we take all the remaining elements, right? We just saw the algorithm. And that's how we have the final answer into our ARR. Okay, so now let's look at the time complexity. See, at the beginning itself, we discussed about time complexity. And it's very easy to understand. At the time of merge, you take this array and you take this array. You iterate on these two arrays and create left and right. After that you merge left and right array by using the algorithm that we just discussed, by using two pointers, and you create the answer. You arrange the element in proper order and create the answer. You do this for this element, you do this for this element. Likewise, you do this for these two elements as well. Once you process any element, then that element will not be processed at that particular stage. What does that tell you? We are processing every single element once. So, it will take O of n time to move from this step to the next step. Again, it will take O of n time to move from this step to this step. So now the question is, how many steps will be there? Look at this. You have an array here, you have n by 2 arrays here, and you have n by 4 arrays here. Likewise, you will have 1 by 8 arrays here. After that, you will have n by 16 arrays. After that, you will have n by 32 arrays. And we will do this till we reach 1. That means we start from n, we divide it by 2, again we divide it by 2, again we divide it by 2, till we reach 1. And this is exactly the logic that we saw in log of x base k. It tells me that how many times do I have to divide x by k to reach 1. So the total number of steps are going to be log of n base 2. Look at this. Here n is 4. So log of 4 base 2 is going to be 2. So there are exactly 2 steps. 1 step and 2 steps to reach the final answer. So total number of steps are log of n base 2. And every single step will take O of n time to process. So the final time complexity is going to be n into log of n. See, initially we have 4 array, then we have n by 2 array. That means we have 2 different arrays. Then we have finally 1 array. So you start from n. Again you club the 2 arrays into 1. That means total number of arrays will be decremented and it will be reduced by half. Again the same thing will happen. The total number of arrays will be reduced by half. Again the same thing will happen. Total number of arrays will be reduced by half till we reach the final stage, that is only 1 array will be left. So O of n time is required to move from one step to another step. Total number of steps are going to be log n base 2. So the time complexity is going to be n log n.